For this lesson, we're going to have a look at how we can use the synthetic division algorithm. The synthetic division algorithm is a division algorithm we can use to divide a polynomial by a linear factor, but the advantage of this is it works in a really fast manner. So it's a dirty trick we can do to divide a polynomial by a linear factor, and it's quick. Now, looking at the first one, we have this polynomial upstairs, and we're dividing this polynomial by the linear factor down here. To do synthetic division, I first set myself up for success by looking at the divisor. In the divisor, I see it's an x plus 3. From this, I'm going to pull out what I call a k, and the k is going to be the negated part of the constant here. So if this is plus 3, my k is always going to be the negative version of that. So in this instance, it's k equals minus 3. Next, I'm going to jump into the algorithm. The algorithm itself is going to start off with k. And then I'm going to write all of the coefficients of the polynomial in a linear fashion. So I go 2, 11, 11, negative 11, and 3. Next, I set the algorithm up by drawing the framework around it. Between the k and the coefficients, I drop a line, and then I bring my line across. Next, I put a 0, and finally, I put a notch. Alright, let's jump into the algorithm. We're all set up. The way the algorithm works is I sum down the columns. So looking at the first one, I have a 2 plus 0. I'll sum that to give me 2. Next, what I'm going to do is I'm going to multiply diagonally. So I've got minus 3 times 2. Minus 3 times 2 is negative 6. So I'll put my negative 6 here. Next, what I'm going to do is I'm going to sum down the column. 11 plus minus 6 is going to give me 5. And then I multiply with the minus 3 here. So minus 3 times 5 is 15, but it's negative 15. (11 plus minus 15 is going to give me negative 4. Multiplying diagonally. 3 by 4 is 12. They're both negative, so it's negative 12. Next step, negative 11 plus 12 is going to give me 1. And then minus 3 times 1 is going to give me negative 3. 3 plus minus 3 gives me 0. And thus my algorithm is over. Now, interpreting the results of the algorithm, over here, this is going to be x to the 0, x to the 1, x to the 2, x to the 3. This over here is our remainder. Putting the result together, this division over here is equal to 2x cubed plus 5x squared minus 4x plus our constant of 1. If we have a remainder, then we would write it as plus the divisor was x plus 3, and there's 0. In this case, because it's 0, we don't need it. So synthetic algorithm or synthetic division works by first determine your k as seen by the divisor. We negate the constant factor. Then after that, we write the k, list all the coefficients. We put a bounding box and set ourselves to 0. We sum down the columns, and then we multiply the result with the k value over here, moving it diagonally. We do this all the way until we reach the end, which is our remainder. All right, next level of complexity. We're going to look at a question where the outcome is going to give us a remainder. What we'll do is we'll observe how we can represent that. Starting off, I have polynomial with a divisor. I get my k factor. My k is going to be determined by looking at the constant. In this case, it's negative 2. Because it's negative, I negate it and it becomes positive 2. Moving along, I set myself up. I'm going to list the k. In this case, it's 2. Then I list all the coefficients. 3, minus 6, 2, negative 9, and 3. Doing the bounding box, and put the 0. Alright, we sum down the columns and then we move the result diagonally after multiplying it by 2. Carrying this out, 3 plus 0 is 3, times the 2 is going to be 6. Minus 6 plus 6 is 0, times the 2 is still 0. 2 plus 0 is 2, 2 times 2 is 4. Minus 9 plus 4 is going to be negative 5, times the 2 will give us negative 10. And 3 plus the minus 10 is going to give us negative 7. Putting this together, we see that this is x to the 0, so our constant. This is x to the 1, x to the 2, x to the 3. This, of course, is our remainder. Writing this out, 3x cubed plus 0x squared, so we don't need to write it, 2x minus 5. Then we have our remainder. Our remainder can be written by, put a plus, negative 7, followed by the divisor here. If you want, you can move the negative out front. Thus demonstrating how we can apply the synthetic division algorithm. Now, where would you use this? Well, synthetic division is useful because it is fast. It is faster than partial fractions. It is faster than algebraic division. However, this only works if you're dealing with linear divisors here. So x plus or minus k. It doesn't work if you're using a quadratic or anything higher than linear.